Here I'm going to look at a Leaving Cert algebra question. It comes from 2018, paper 1, question 2. You're told the first three terms of a geometric series are x squared, 5x minus 8, and x plus 8, where x is a real number. Use a common ratio to show that this is true. Okay, well, it's saying to use a common ratio. So when we've got a geometric series, we know that term n divided by term n minus 1 is equal to term n plus 1 divided by term n. That means any term divided by its preceding term is equal to another term divided by its preceding term. So what we can do is that allows us to set up an equation where if we've got three terms here, what we can say is that 5x minus 8 over x squared is equal to x plus 8 over 5x minus 8, where that 5x minus 8 is our middle term here. We'll just call that term n. This term here is our next term, and this term here is our preceding term. So we'll just cross multiply. We're left with 5x minus 8 by 5x minus 8. So that's 5x minus 8 squared is equal to x squared times x plus 8. When we expand that out, we've got 25x squared minus 80x plus 64 is equal to x cubed plus 8x squared. So we bring it all over to one side and we're left with x cubed minus 17x squared plus 80x minus 64 is equal to 0. So we've just shown that. Okay, so they brought in a bit of sequences in that question, but if you can cross multiply in the algebra part of it, then you'll be fine. You're then told that if that cubic, because we know it's a cubic because the highest power of x is cubed, if that cubic is true, show that f of 1 is equal to 0. Well, what that means is just plug in 1 for x. So we're going to be 1 cubed minus 17 times 1 squared plus 80 times 1 minus 64. And we're going to show that's equal to 0 because we've got 1 minus 17, which is minus 16, plus 80, which is plus 64, minus 64. That is equal to 0. So that is true. Find another value of x for which f of x is equal to 0. So this is an algebra question involving cubics, which means we're asked to solve the cubic equation. So what they've told us is they've given us the first root. Now, if you're not given the first root in a cubic, what you can do is just use trial and error. So you will look at the constant and plug in factors of that constant, starting at the lowest because it's easiest, until you get a result of 0. That tells you that's a root. Now, the root is where that curve touches the x-axis. Now, for more on that, you can have a look at the video online on rmcstudy. If we know the root, so the first root is equal to 1. So therefore, x minus 1 is a factor. So that means when I divide x minus 1 into the cubic, x cubed minus 17x squared plus 80x minus 64. Okay, I'll end up with a quadratic equation, but what I'll do is I will be getting the other factors from that. So there's a number of ways of doing it. You can do the long division method, you can use the box method if you want, or any other methods. So just doing some division, x into that goes x squared times both of those gives you x cubed minus x squared. Change the signs and add, and you're left with minus 16x squared, and bring this down, plus 80x. X into minus 16x squared gives me minus 16x. Then I multiply that in. Minus 16x times x is minus 16x squared plus 16x. Again, I'm going to change the signs and add. I'm left with 64x minus 64. Well, x into 64x goes plus 64. Multiply that in, and I've got 64x minus 64. So when you subtract them or add them, change the signs and add, you get 0. So that means that here is another factor, but I know because it's a quadratic, it's actually made up of 2 factors. So if I just take it to the side, x squared minus 16x plus 64, if I just factorize that, that is just going to be our square, x minus 8 times x minus 8. So x is equal to 8. So we've got another value of x there, for which f of x is equal to 0. The last part of the question then, in the case of one of the values from x from part B, the terms in part A will generate a geometric series with this finite sum to infinity. Find this value x and hence find the sum to infinity. Let's have a look at both values. Well, when x is 1, we plug it into the original. So the original here was x squared 5x minus 8 and x plus 8. So we've got x squared 5x minus 8 and x plus 8. So let's have a look at the first few terms. When x is 1, we've got 1, 5 times 1 minus 8, which is minus 3, and then 9. I can see that I've got alternating terms here. So to find OR for this one, just to go through, it's going to be tn over tn minus 1. So we could look here, we could say it's minus 3 over 1, or 9 over minus 3. Or there is minus 3. So what that means there is we don't have a finite sum there. As our number of terms gets bigger and bigger and bigger, so does our sequence, okay? And it'll go up and down because the ratio there is minus 3. When I look at the other one, so it's obviously going to be x equal to 8. We're going to plug it in. We've got 64. 5 times 8 minus 8, we've got 32, and we've got 16. So OR in this case is going to be 32 divided by 64, so it's a half. Here I will have a sum to infinity, and I'll just look up the tables. The sum to infinity formula is a over 1 minus OR. So our first term, 64, will be 64 over 1 minus a half, which is a half. Okay, so 64 divided by a half is the same as 64 multiplied by 2, gives me a sum to infinity there of 128. So that's adding all of the terms together, and that's the terms going up towards infinity. And I have a finite sum there, and it's 128. Okay, because the modulus of OR was less than 1. That means I've got a finite series.